So we are back up at Lucky Boy, a few miles south of Hawthorne, Nevada. That's on the northwestern side of the state. For exact instructions on how to get to Lucky Boy, see the first video in this series. When you get to this foundation on the left-hand side of the Lucky Boy Road, park. For the first video, most of the footage was taken just above the foundation, towards the west. But now walk across the road so you can look down the grade you just came up. This is towards the east. There will be a small side road that takes you directly down the hill. If you walk that hill, then you will end up at these larger mines. Also, there are several mines and loads of trash in a small canyon just ahead here. The main road is exactly as it was more than 100 years ago, so we can see from this picture, which starts just after the foundation left behind today, the area we just looked at was full of buildings more than 110 years ago. This is the area we will spend our video time today. So if we wander just across the road and angle ahead, north, you will come to a series of open-air prospects. These will give you some idea of what type of strata the old-timers were searching through. This is a complex geologic area, and in some places the silver was found in quartz-like seams traveling through a type of chert-like material. There are some examples of this here in the small ravine. If you are going to metal detect for silver deposits here, try looking for the exposed seams of oxidized quartz. Here is an example. This particular seam was exposed by a road. Typically, when you find a seam, it is usually incorporated in a larger swarm. So look carefully through the whole area, not just exploring what you immediately find. Though there is some quartzy float and seams throughout this small ravine area, the better ore examples come from where the larger mines are, just to the south. Here you can see copper and some pyrite incorporated into the lode. There is a tremendous amount of trash around the small ravine, from cans to bottle parts to broken china, to the round metal banding that held water barrels together, to tin for roofs, or tin that encircled and protected a tarp from stovepipe. This looks to be part of a stove. And here we have the top of a ragtag building that is rolled down the hill, with a hole for a stovepipe still intact. This looks to be a telegraph pole. If you head slightly further down the hill and south past another very small ravine, you will come to a series of large mines. These all supported head frames. You will find their foundations poured in concrete. Like all of the large mining activities in the area, the shafts are universally steeply inclined and very deep. The wooden collars have been salvaged around all of these shafts, so the lip to the shafts are especially dangerous. It won't matter if it is a shaft or a portal. It is always the area where the cut meets the outside world that is the most unstable, being by far the most susceptible to weathering. So stay well aware from these shaft openings. There is not a single one you can safely get down without substantial climbing material. I have read that several of these shafts are actually over 1,000 feet deep. Further up the hill, just below the main road, there are some prospects. Here the rock is more sedimentary with a lot less mineralization and is generally quite unstable, being very crumbly. I would not spend any time inside these. There is nothing to gain and everything to lose. I did find this cold steel chisel inside some remains. If you take a look at the bevel, it has 3 angles. This indicates that the chisel was intended for very hard rock. That is opposed to a bevel that is completely flat, which would be used for softer rock. Also, with this chisel, the flare is very slight, as opposed to something longer. Again, that indicates this was intended for very hard rock. This chisel was made for single jacking. That is, the same person who placing the chisel would also be hitting it with an iron mallet. The chisel design is octagonal, and after each strike, the operator would rotate the chisel an eighth of a turn. In all cases, the chisel was used to prepare rock for blasting. This technology was replaced by a more modern design around 1905.